Hey everybody, Chapter 2, Section 6. Title is Ratios, Rates, and Conversions. Starts on page 118. Couple of definitions. A ratio is a comparison of two numbers by division. It's kind of like a division problem. Ratios can be written three ways, three different kinds of notation. You can write it as a fraction, a over b. You can write it with a colon, and you can write it with the word 2 in the middle. Okay, now, when we say it's like a division problem, if we think about a classroom full of students, if we have 20 boys and 10 girls, I can write that as a division problem. And if I simplify it, that would be my ratio. So if I simplify 2 over 10, I get, or 20 over 10, I get 2 over 1. And so that would be the ratio 2 to 1, which means for every 2 boys, there's 1 girl. Now, you can also think of a ratio as like a multiplication, because in the one we just did, there are 2 times as many boys as there are girls. If I had a ratio that was 3 to 2, there would be 3 times the number of boys and 2 times the number of girls. So for every 3 boys, there were 2 girls. So I just write it as a fraction and then I simplify it. Another example, 3 to 1 means that I have 3 times more of the first thing than I do the second thing. Another definition is rate. A rate is a specific kind of ratio. A rate is a ratio that compares two things that have different units. A good example of that is speed limit. Okay? Speed limit is a rate because it's comparing two different things. It's comparing a distance, like miles, and it's comparing a time, like hours. So miles per hour would be a rate because it's comparing two different things. One more definition. A unit rate is a rate that you write that has a denominator of 1. So you're trying to simplify the fraction so that there's a 1 on the bottom. We'll talk more about unit rates. Unit rates, the most often time that you use them is when you're trying to figure out the best deal if you're trying to shop or buy something or something like that. And here's how it would work. It says, which is the better buy? 6 bagels for $3.29 or 8 bagels for $4.15. What you're really trying to figure out, what you're trying to know, is how much one bagel costs for each of those two prices. So you're going to turn them into unit rates. You want to know how much one bagel costs. So you're going to do $3.29 for 6 bagels. You're going to do $4.15 for 8 bagels. And you're going to take those two and you're going to simplify the fractions so that there's going to be, grab my calculator here, and I'm going to do 3.29 divided by 6, and my calculator says 0.548, and that means that there's a 1 on the bottom because I divided by 6. And I'm going to also do 4.15 divided by 8, and I get 0.519, and now there's a 1 on the bottom because I divided. Now what this tells me, over here on the left, for the one that had 6 bagels, this means that one bagel is about 55 cents. Over here on the right, one bagel is about 52 cents if I round that. So the one that's the better deal, that's going to be the one that's cheaper. So it's cheaper to buy 8 bagels than it is to buy 6 bagels. That's how a unit rate works. Next type of problem we have to do is called a unit conversion. Conversion means to change from one to another. And so I'm going to change the units that are in the problem to another type of unit. In order to do a unit conversion, you have to multiply the original problem by what's called a conversion factor. If you look at the word factor, the beginning of that is fact. Okay? A conversion factor is a fact that is true about two related units. For example, what I mean by related units, feet and inches, those are both measuring distance or length, right? So those are related units. A fact about foot and inches, well, 1 foot is equal to 12 inches. So that would be an example of a conversion factor, a fact that is true about those two units. Now, the method that I use for unit conversion is called the railroad track method. I've been doing this for a long time. This is the simplest way I have ever figured out in any of my classes, and it works for science classes, it works for math classes. And so it's the simplest way I've ever figured out how to do it. There's one key. You have to use your conversion factors correctly. And I'll show you the only common mistake that people make when they use this method as we go through a couple of examples. Here it says, what is 1,250 kilometers converted to meters? So we're starting with centimeters, and we're trying to turn it into meters. Now, here's how the railroad track system works. I'm going to write what I start with, 1,250 centimeters, and that's a whole number, right? So I'm going to put it over 1, because I can put a whole number over 1. See how these lines in here end up looking like railroad tracks? It looks a little bit more like railroad tracks if we do a longer problem, which we'll get to. So now, I have my conversion factor, my fact that 1 meter is 1,000 centimeters. There's two ways I can write that. I'm going to write that as a fraction, but I could write it as 1 meter over 100 centimeters, or I can write it as 100 centimeters over 1 meter. One of those is going to be right, one of them is going to be wrong. The only way you can get a problem like this wrong is if you pick the wrong fraction. Okay? Here's how you can tell. Centimeters is on the top of my problem over here. I don't want centimeters in my answer. I want meters in my answer. So in order to get rid of centimeters, which is on the top, I need centimeters to be on the bottom when I use the conversion factor. Which one of those two fractions has centimeters on the bottom? Well, it's this one. Okay? So I'm going to plug that in. 1 meter, 100 centimeters. Now, the reason why I have centimeters on bottom is because if I have the same thing on the top and on the bottom, they cancel. So the centimeters on top over here cancels with the centimeters on the bottom. What is the only unit that I have left in this problem? It's meters, and that's what I'm trying to get in my answer. Once I do that, next it's just like multiplying fractions. So I go straight across the top, 1250 times 1, which is 1250, and on the bottom I get 1 times 100. Finally, I simplify. So I do that on my calculator. 1250 divided by 100, and I get 12.5. Now, the whole point of this problem is units, right? You're talking about centimeters, you're talking about meters. You have to put a unit on your answer, because I don't know if you're talking about 12.5 meters or 12.5 centimeters or 12.5 hippopotamuses again. So I have to put my unit. The only unit that's left is this meters, so that's what goes in my answer. Let's look at another one of those. A building is 1,450 feet tall. How many meters tall is the building? So we're going to start with what they tell us. 1,450 feet. That's a whole number, so I'm going to put it over 1. It tells me that my fact is that 1 meter is equal to 3.28 feet. So I need to figure out how to write that fraction. Is it 1 meter on top? Or is it 1 meter on bottom? Well, let's look at what I've got so far. In my problem, I have feet on top, so in order to get rid of it, I also need feet on bottom. So I'm going to use that fraction right there. 1 meter on top, 3.28 feet on the bottom. The reason why I do that is because now I have feet on top and bottom, so they cancel. The only unit I have left is meters, and that's what I'm trying to get in my answer, so that works. Multiply across the top, multiply across the bottom. 1450 times 1 is 1450. Drop my eraser. One times 3.28 on the bottom is 3.28. And now I use my calculator to divide. 1450 divided by 3.28. And I get that my answer is 442.1 if I round. And what's my units here? I crossed off all my feet, so the only thing that's left is meters. So that would be 442.1 meters is my answer. Now, when you use the railroad track method, sometimes it's more than one step. So far in these problems, we've only had to use one fraction. Okay? The next one has a few extra steps in it. An athlete ran a sprint of 100 feet in 3.1 seconds. What was his speed in miles per hour? Round to the nearest whole number at the end. So look at what we're starting with. We're starting with 100 feet and 3.1 seconds. So our railroad tracks are going to end up looking like this. I think there's one more. Okay, that's what we're going to fill in. We're starting with 100 feet. That's going to go on top. And we're going to start with 3.1 seconds on the bottom. Now, we're trying to go from feet to miles, and we're trying to also go from seconds to hours, so we have to make a couple of changes. It doesn't matter which one I do first. Okay? I'm going to change feet first. And so the fact tells me that 1 mile is 5,280 feet. So I can write that as with 1 mile on top or with 1 mile on the bottom. Well, I already have feet on top, so in order to cancel that, I have to have feet on the bottom. So I'm going to put 1 mile, 5,280 feet. Okay? The reason why I do that is because now the feet on top can cancel with the feet on the bottom. Okay, let's look and see what units I have right now. I have miles and seconds. I don't want miles and seconds, I want miles and hours. So now I have to change those seconds. Well, I have a fact about seconds right here. 1 minute is 60 seconds. So how would I write that fraction? Well, I already have seconds on the bottom, so I need to have seconds on the top when I write it as a fraction. So I'm going to put 60 seconds over 1 minute. Seconds on the bottom cancels with seconds on the top. And right now my units are miles and minutes. I don't want miles and minutes, I want miles and hours. So I have to change minutes to hours. My fact for that is right here. 1 hour is 60 minutes. I already have minutes on the bottom, so in order to cancel that, I need minutes on the top. 1 hour on the bottom. Minutes on bottom, minutes on top, those can cancel. And the only units I have left are miles and hours. What am I trying to get? Miles and hours, right? So once my units are correct, then I can just multiply everything else out. So multiply across the top. Grab my calculator. On the top I have 100 times 1 times 60 times another 60. And I get 360,000. On the bottom, I have 3.1 times 5,280 times 1 times 1. And I get 16,368. I'm going to divide those two. And I get 21.99. Okay. And we had miles and per hour. Per hour. Okay. Look back at what the question asked. It said round to the nearest whole number at the end. So if I round from 21.99, I get 22 miles per hour. Okay? As long as you know those facts, you can figure out how to write your fraction with what part being on top and the other part being on the bottom, and then just multiply straight across the top and straight across the bottom. Divide once you get to your final answer. Practice problems for this section.